Let us continue our discussion on finding the nth term in an arithmetic progression sequence, or in short, we will say that it is an AP sequence. Okay. Now, we have learned in the past that a general representation of the nth term in an AP sequence is an is equal to a1 plus n minus 1 times d, where a1 is the first term, n is the nth term we are looking for, and d is the common difference between two successive terms, right? It's a very straightforward, simple formula, all right? So to best see the utilization of this formula and how to build stronger understanding in the AP sequence, let's go through a couple of examples. So my first example is this. We are supposed to find the 50th term of a sequence as given below. So it is 6, 12, 18, 24, and so on, right? So what do you find from this sequence? That I see that the first term is 6, so it is a1, right? And the difference between any two successive terms is always 6, right? So this is an AP sequence, correct? So now we know the value of the very first term. We know the common difference. It is d, right? So we will write it here. a1 is 6 and the common difference is also 6. Then you will say that to find the 50th term, it is very simple. We will simply write here a50 is equal to a1 plus 50 minus 1 times d, right? Or you will plug in all the numbers and then you will say that the first term is 6 plus 50 minus 1 times 6, and this will be 6 plus 50 times 6 minus 6, or it is equal to 300. So it is indeed very easy to find the 50th term using this formula, and the answer is 300. Now, why exactly we have to find the 50th term like this is only because that if you were counting the number of terms and then increasing one at a time, then it would take you really long time to get to the 50th term, right? That's why we simply make use of this formula. So to prove the point, let's go through one more example to find a good and valid application of these kind of formulas. So in this one, Dennis, he starts repaying a loan with the very first installment of $250, and if he increases the installment by $5 every month, what amount will he pay in the 30th installment, right? So think about this, that starting from month 1, this gentleman is paying $250. Then the next month he goes up, he pays $255. Next month he goes up another $5, and then it keeps going up like this, right? Now, if you were to really go like this and make an increment of $5 every month, then it will take you really long time to compute the 30th term. Rather, what we do is we will make use of this formula that we have, because what you see here is a1, which is my very first term in this sequence, is 250. And the difference between any two successive terms is always constant. It is 5, right? So this is a perfect example of an arithmetic progression sequence. Hence, we can make use of this formula, right? So in this case, we will say, what is my 30th term? That will be a1, and a1 is 250 plus n minus 1. Since n is equal to 30, so we will say it is 30 minus 1 times the d, where d is equal to 5. So it will be times 5, right? So let me write here, it is d. Now it is simple and straightforward to handle. So it will be 250 plus 30 minus 1 times 5. And when you solve this mathematics, it will be equal to 395. So Dennis will pay $395 in his 30th installment. Simple and straightforward, right? Let's take one more example. Which term of the AP sequence, and this is my sequence here, will be 132 more than its 54th term? Okay. So let's identify few parameters of this AP sequence. It is a1 is equal to 3, and the d, the common difference between two successive terms, is equal to 12, right? So 3 to 15, the difference is 12. 15 to 27, the difference is 12, right? So you know this value now. Now, what is my mth term? am, it will be denoted that way. And by this statement, I'm saying that the 54th term, when you subtract from the mth term, it will be equal to 132. That's what this sentence is telling us. Now, let's substitute these values from this general expression. Am will be equal to a1 plus m minus 1d, right? Minus a54 will be a1 plus 54 minus 1d, right? We know this much, and this is equal to 132. So you see that a1 will be cancelled out because there is one negative sign right here, right? So when you simplify this whole thing, it is m times d minus 53d. I'm getting 53d from here, correct? This is equal to 132. Or when you want to simplify even further, you will say that m times d is equal to 132 plus 54d, because these two values will be combined, and once you transpose to the right hand side, you will basically reverse this negative sign. This can be stated that the value m is equal to 132 plus 54 times d divided by the d overall. So that will be equal to 132 plus 54 times 12 divided by 12. So when you solve all of this mathematics, you'll find that this answer is equal to 65. All right. So the value of m is equal to, this value is equal to 65. So it is the 65th term will be 132 more than the 54th term. Okay. So in all three examples that you have gone through, you see that we have simply made use of this formula. It is, how do you find the nth term? All right. So with that, we take a pause here, and in our next lesson, we are going to learn about how do you find the sum of n terms of an AP sequence.